We rely on permanence every single day, right? I mean, think back to your old math classes. We're taught basically as gospel that equations are the ultimate bedrock of reality. Your algebra teacher probably promised you they hold forever. 1 plus 1 is 2 today, it was 2 at the dawn of time, and it's absolutely going to be 2 at the heat death of the universe. It's a comforting thought. But the text we're breaking down in today's explainer, yeah, it takes a sledgehammer straight to that comfort. It completely challenges the foundation of mathematical permanence. Okay, let's dive into this. So here's the big question the author opens with. Do equations hold forever? It's beautifully simple, but honestly, it's incredibly disruptive. Is that really true? The author doesn't just want us to nod along to this dogma of endless mathematical truth. They really want us to interrogate it. As we go through this, I want you to hold this specific question right in the back of your mind. Try not to just reflexively answer yes, just because that's what we've always been told. We're going to use the author's own logic to test the strength of our certainty.
All right, let's peel back layer 1, the forever assumption.
Before we even get into the math, we kind of have to look at how we as humans perceive time. The text hits us with a highly practical question right out of the gate. What does forever actually mean in this context? I want you to actively think about this. When we talk about human-made mathematics, what are we really claiming when we throw around a phrase like forever? Think about it. We're finite beings living on a finite planet, using completely finite brains to scribble down symbols. And yet, we're slapping an infinite guarantee onto our equations. The author brilliantly points out the extreme arrogance, or maybe it's just a huge blind spot, in defining things this way. And that brings us to the actual data, a few thousand. Now, what's really interesting here is the totally stark contrast between our everyday reality and the enormity of the claims we make. The author reminds us that most of these formulae have really only been around for a few thousand years, max. I mean, the Pythagorean theorem, it's barely 4,000 years old, yet we attach absolute, infinite guarantees to it. Just think about that for a second. We've been testing these supposedly eternal mathematical truths for a microscopic sliver of cosmic time. When you actually map this out on a timeline, it really puts things into perspective. So from year 0, like the absolute dawn of recorded history and mathematical thought, to where we are right now, it's a few thousand years max. But then, stretching way, way out to the right is the concept of eternity, forever. When you view it like this, our sample size is incredibly, almost embarrassingly tiny. The author is essentially suggesting that claiming an equation holds forever based on a few thousand years of observation, well, that's a massive leap of faith. It's an assumption based on a literal blink of an eye. Let's move to layer 2, the precision illusion, and see how this builds.
So now the author's argument shifts. We're moving from our limited human time frames directly into the structural flaws of the formulae themselves. The text calls out a few specific culprits hiding inside our supposedly perfect, eternal mathematical structures. You definitely know these symbols. Infinity, pi, the square root of 2. These are the heavy hitters, right? They're completely baked into the equations that govern physics, engineering, the whole shebang. We treat them as absolute, unshakable pillars of truth. But the text asks us to look a little bit closer at what these symbols actually represent in practice.
And this brilliantly illustrates the core mechanical flaw the author is trying to expose here. We walk around treating things like pi or the square root of 2 as exact numbers. But the text is super blunt about this. Formula containing these symbols are approximating numbers at best. Why? Well, because you literally can't ever write down the entirety of pi. You'd run out of universe before you ran out of digits. You can't perfectly resolve the square root of 2 or pin down infinity. We have to round them off. We basically have to approximate them just to make them work in our human equations. The author argues that if the very building blocks of our equations are just approximations at best, how on earth can we guarantee absolute perfection for all of eternity?
Which leads to this wild, fascinating hypothesis from the text. Perhaps something else will make them stop from being true all the time. Look, if our math is based on approximations, and our window of observation is just a few thousand years, there's a vast, terrifying amount of room for error. The author is hinting that over the course of true eternity, external, unknown variables, this mysterious something else, might eventually act on these approximations. A margin of error that seems completely invisible over 1,000 years, it might compound over 1 trillion years, causing the entire mathematical framework to just buckle and fail.
Which brings us to layer 3, the metaphysical collapse.
Okay, here is where the text takes a sudden, really profound turn. We are totally leaving the realm of pure analytical math behind now. Because think about it, if the numbers aren't eternally solid, if our timeline is just a wild guess, the very foundation beneath our feet starts to crumble.
The author definitely senses this, and the whole tone shifts radically inward. It becomes deeply intimate, kind of mysterious, triggering this rapid-fire cascade of Socratic questions. The author starts with this massive foundational query. What can we be sure of? If the absolute bedrock of human logic, mathematics, is built on approximations that might literally expire, well, what else is vulnerable? Just take a moment. Let the weight of that question sink in. What in your life or in our universe are you absolutely 100% sure of?
So the crucial point is how the author pivots our attention right here. We look away from the external universe, away from the equations and the timelines, and we look directly in the mirror. What do we mean by we? If our external tools for measuring reality are flawed, the author is questioning the very observer holding the tools. Who exactly is the we that assumes mathematics holds forever? Is our collective human identity just another temporary approximation?
And the text pushes even further, asking, are we that separated? This challenges our deepest perceptions of boundaries. We go through the world experiencing it as separated beings, right? You're over there, I'm over here, the math equation is on the page, the universe is out there in the sky. But if the rigid rules of math are just an illusion created by our short lifespans, perhaps our perception of separation is an illusion too. The text completely dismantles our concrete sense of a divided, categorized reality.
Which leaves us with the final, most profound question from the source material. 3 simple words that just echo through the void left behind when you strip away our assumptions, our timelines, and our mathematical certainty. What is real? It's the ultimate culmination of our journey today. We started out by questioning a simple math equation, and we ended up questioning the very fabric of existence. I'm going to leave you with that thought. Let it provoke you. Let it make you hungry to explore deeper. Thanks so much for hanging out with me for this explainer today, and I'll catch you next time.